Hi, today I'm gonna show you how to solve ROP Emporium's challenge callme. We're gonna solve both the 32 and 64-bit versions, so let me run it. As you can see, they are the usual binary. They just read a string and then exit. So let's open with GDB the 32-bit version. We list the functions inside the binary. We have the main function, the pwntools function containing the buffer overflow, a useful function, and three weird functions in the PLT. Let's disassemble these functions. The main just calls pwntools. Here we have the vulnerability that we have to exploit. This function contains the three calls to the functions we saw in the PLT. The text of the challenge tells us that we have to call these three functions in order 1, 2, 3 with parameters 1, 2, 3, and we're gonna get our flag. So let's take note of these addresses. Since we are on 32 bits, parameters are passed to functions through the stack. So when we are inside these functions, for example, when we are at the first instruction inside the callme, we have on the stack the saved return pointer and then our parameters. So inside our ropchain, we're gonna have the address of the function, the return pointer of the next gadget, and our parameters. The next gadget should adjust the stack in a way that we can proceed with the execution of our ropchain without crashing. To achieve this, we need a gadget that in some way changes the value of the stack pointer. So let's check what gadgets we have with the ROP gadget. And you may notice that we have this gadget that increments ESP by 8, then it pops EBX, so it will increment ESP of 4, and then we return. So we can use this gadget to skip our parameters in the ropchain. Let me show you graphically what we want to do. We have the address of our target functions, then we have a return pointer, and then we have our parameters. So when we executed the instruction at this return pointer, the stack pointer points to the first argument. So when we increase ESP by 8, we jump over the first two arguments, and then with the pop we skip also the last one, and we can go on with our ropchain. So let's try this payload, and it works. We get our flag. Let's move to the 64-bit version. We list again the functions. We have the same functions as before, plus useful gadgets. We disassemble again the functions. And now you may notice that since we are on 64 bits, the parameters are passed through registers. So our ropchain will have to take care of setting the registers to the correct arguments. And inside the useful gadgets, we have precisely what we needed. So a gadget to set RDI, RSI, and RDX. So let's build our ropchain. Now we just have to find the correct offset to override the saved return pointer. So we have 40 bytes of padding and then our ROP chain. And erase the flag. So let me now show you how to write an exploit with pwntools to automate what we did manually. Of course, we need to import pwntools. We're gonna also need the sys. Then I'm gonna pass the binary to exploit as an argument to our program. So we check the number of arguments. Then we set the binary to the argument. Depending on the architecture of our binary, we set the offset, and then we are ready to build our ROP chain. We don't need to hard code anything. We're gonna reuse code from our binary, and now we can just tell pwntools to call the functions that we need, and it will try to automatically build the ROP chain for us. In this case, it's quite simple. It just has to find the same gadgets that we find manually. We print our ROP chain, then we create our payload. We can use fit to tell pwntools to create a payload which has our ROP chain at the chosen offset, and pwntools will pad the space using by default a debrugging pattern. Otherwise you can specify anything else you want. And now we are ready to send our exploit, and we'll print the flag that we'll hopefully get. Make the exploit executable. Let's try first the 32-bit version as a target, and it works. As you can see in the ROP chain, we have the same gadget that we found manually to adjust the stack pointer. Let's move to the 64-bit version. Again, even in this case, the gadget found by pwntools is the same that we found manually. So this is how you could quickly write a general payload to solve both the 32 and 64-bit version of the challenge. And that's all for today. See you next time.